Crepuscular rays, what we see and experience. Look at that. That that just never gets old, does it? So, why does this beautiful phenomenon happen? Let's explore that question. Crepuscular crepuscular rays is the technical term for all of the different names you see here. There's a lot of names for crepuscular rays. Sun rays, sunbeams, cloud breaks, fingers of God, I like that one. Jesus rays, shafts of light, backstays of the sun. I've never heard of that one. Volumetric lighting, that's actually a term from the 3D animation world. God rays, sun drawing water, that's interesting. Ropes of Maui, I think that is. Tyndall rays, that's interesting. So there's a lot of names for crepuscular rays. The modern science explanation. Some beams are parallel shafts of sunlight passing through gaps in clouds. Their apparent convergence is a perspective effect, similar, for example, to the way parallel railway lines seem to converge at a point in the distance. We are going to explore both of these one at a time. So let's look at the sunbeams are parallel shafts of sunlight passing through the gaps in the clouds first. What we need to do is understand the relationship between the Earth and the heliocentric model. And what we have here are the various um, distances and size relationships between the Earth and the Sun in the heliocentric model. Of course, this is not to scale. The Earth would be much, much smaller. But as you can see, these vast differences in sizes and the distance. You have the Sun at 93 million miles away from the Earth, which is really important for this study. So we have here, the most important part here are the way the rays of the sun hits the comparatively small planet Earth. And the rays of the sun are huge um, because the sun is so huge. And the rays of the sun are much larger than the Earth. Just one ray from the sun is just so much, thousands of times larger than the Earth. Let's keep that in mind. Because the moon is also a source of crepuscular rays, we are going to explore the relationship between the moon and the Earth. So we have the same type of measurements here. You have the size of the moon, the size of the Earth, the distance that the moon is from the Earth, which is 238,000 miles roughly. That is the most important thing to remember from this diagram. All right, let's look at some NASA photos. These are straight from the NASA website. If you go to NASA, punch in crepuscular rays, you will actually get this photograph. So we have here NASA's evidence of horizontal sunbeams shining down on Earth from the sun. So, so basically what you're looking at is a high altitude photograph of the of a cloudscape, and you can see the bright highlights on the backs of these clouds and the deep shadows on the other side, which means the sun is low in the horizon. And also the long shadows you have here. And let's keep that in mind. These are not light beams shining down on the earth. These are actually shadows being cast from a low point of view sun on the cloudscape. Let's look at this one here. This is a closer view of a different photograph, and these are supposed to be horizontal light beams shining down on the earth. Actually, they are, um, this looks like water here, and these are actually shadows. These are long shadows due to a sun low in the horizon. And you see the highlights here and the shade on the other side of these clouds. And that's what you're looking at here. Um, right here, these are the spaces between the shadows. Those aren't light beams. Those are the spaces. Those are the space between the shadows. Here you have another example, completely different photograph. Oh, by the way, I did not retouch these or anything like that. These are straight from the NASA site. So you have, again, these are supposed to be light beams that are shining down on the earth. They're actually shadows, and these are the spaces between the shadows. So let's look at how that works. So you have the sun here, and I have this little house, and what they're saying is that as the sun goes down in the horizon, it causes these long shadows. Um, that's how you get long shadows when the light is at a low point of view in relation to the object, the obstruction. So that's how you get long shadows. Again, here we have, you saw the little animation, and this is a really clear one. These are long shadows shining upon the surface of this cloud bank here, this cloudscape. They are not light beams that are shining through the clouds down to the surface of the earth. They're not doing that at all, but this is NASA's evidence for horizontal light beams shining down to the surface of the earth, and these aren't shining down to the surface of the earth at all. All right, so based on the horizontal light beam idea, this is what we should be seeing. This is a little illustration I had done. You should have light beams shining through the clouds everywhere, okay? There should be a veritable field of horizontal light beams shining through the clouds down to the surface of the earth everywhere. But when we see crepuscular rays, we always witness this. We see an isolated local expression of crepuscular rays, and they're always converging. Bear in mind, they're always converging no matter where you are in relation to the phenomenon. So um, instead of straight light beams coming straight down, they are actually always converging like this, and they're local. They're not spread out all over the sky. This is what we witness all the time. All right, let's look at real world observation. What is perspective? Let's look at this part. Remember, science said that the the reason why the light beams converge is due to perspective, like what you see on railroad tracks. So, what is perspective? Perspective is based on point of view only. We're going to um, examine that. How something appears is based on its relative distance and position. Okay, let's look at the railroad analogy. So I made this little animation here, and you can see the camera is parallel, the view of the camera is parallel to the railroad tracks. It's pointing straight at the railroad tracks. Okay, you see no convergence here. Um, I'm above the railroad tracks, there's no convergence. I'm right up on the railroad tracks, there are no convergence. But wait a minute, as I line up with the railroad tracks, now I'm getting what's called single point perspective. You're getting that convergence of the railroad tracks, all right? If you notice, it didn't happen until I started to line up my camera view with the horizontal lines, and then I started to get that convergence. All right, this was an animation. Let's look at it in real life. So here we have a, video that I had done of actual railroad tracks. And as you can see, they're converging to one point, a single point perspective. They're converging to one point. But as I move the camera away from that convergence, now I'm lining my camera up with the lines horizontally, and what do you know? There's no convergence. This is what we experience on a daily basis. Really simple stuff. So you look at the camera, you look at the point of view of the camera, and there you have it. But look, as I turn the camera, pan the camera, I'm starting to see that convergence again because I'm lining up with the tracks. All right, and you see that single point convergence. It's pretty cool, actually. And then as you line up with the tracks horizontally, wow, look at this. When your point of view is parallel to the tracks, straight on the tracks, there is no convergence. Okay, let's look at that again. So we're going to move slowly, and as we slowly move, you see them converge because we're lining up with the tracks. Look at that. It's point of view dependent. So now that's my shadow here. So now we're lining up with the tracks horizontally. Okay, as we pan around, we're going to start to see that convergence again as we line up with the tracks, and there you have it. Single point perspective. Okay, all you painters, photographers, and illustrators out there, and engineers and architects, you know this to be true. All right, it is point of view dependent only. Okay, so with those two traits in mind, with the horizontal, looking at the horizontal theory, and also the perspective theory, let's look at what you need to actually create crepuscular rays. Here is a simple formula to create this convergence: obstruction, proximity, and particulates. So in this case, the obstruction will be clouds, the proximity would be the sun, and the particulates, in this case, we're going above water here, would be mist, all right, or fog, could be that too. Also, just to let you know, crepuscular rays does not only happen with stellar bodies like the sun and the moon. It could also happen with streetlights. So you have obstruction would be tree branches, okay? The proximity would be the street light shining through the leaves of the tree. The particulates would be fog, pollution, mist, steam, that sort of thing, smoke, okay? So in this case, the sun has to be very close to the clouds, proximity. The proximity is close. It has to be very close to the clouds in order to cause this convergence. And as you can see, the camera in this photo is not underneath. Remember, with the railroad tracks, you had to be lined up in a specific way in order to get that single point perspective, that single point convergence. But with these crepuscular rays here, this person had to be miles away from the actual phenomenon. Yet the rays are still converging. All right. So what are we talking about here? Perspective has nothing to do with crepuscular rays. It's all about obstruction, proximity, meaning the light source has to be very, very close. We're going to examine that in a minute. Very close to the obstruction, and the particulates. Proximity is the key. Perspective has nothing to do with crepuscular rays. Okay, let's explore that. We have crepuscular ray home experiment. So I created those beautiful crepuscular rays in my home. My rays aren't nearly as gorgeous as they are out in creation, but this at least will prove the point I'm trying to make. So you have here my den, which I tore apart in order to, I'm sorry, this is my patio. And you have my camera, and you have the pan or tray that I have here with baby powder on it. Yeah, that was really funny. So I have baby powder and I have some gloves that you would use to bathe with, you know, to scrub with, and I use those to saturate the gloves with the baby powder. I have here the pegboard with holes in it and the light stands holding up the pegboard. And you could use, I'm a photographer, so I have all this stuff. But you could use anything to hold up the pegboard. You don't even have to use pegboard, use cardboard and just poke holes in it. I drilled some larger holes in addition to all the little holes. This is a humidifier. I was using that to create the particulate, but it didn't create enough steam. So I got rid of that and used the baby powder instead. So remember that formula? You have the obstruction, in this case is the pegboard. You have the proximity, and that is the proximity of this light right here, okay? And which is a little mag light, and it's a LED light. It's very bright and small. So when you're doing this experiment, you need a small, intense light source. Isn't that interesting? It doesn't quite work with a large, bright light because the light isn't focused enough. And so it creates really soft crepuscular rays that aren't as intense and as beautiful as you see out in creation. Isn't that interesting? So, and then the particulates will be baby powder. And that's a funny story, so I'll tell you that in a second. All right, so you have here these, I did this at night. That's the best time to do it. And I have my mag light is very close to the pegboard, and that's where you see these holes. And so since it's very close to the pegboard, it focused the holes. The holes are very large, okay? It created a very large reflection on my carpet. So now I use the baby powder. Well, look at that, crepuscular rays. Here's my light is very close to the pegboard, and look at that. You have at the angle, if you saw my arrows, you have the angle of the light, okay? And it's a sharp angle due to the flashlight being very, very close to the pegboard. It's almost touching the pegboard, okay? And I slowed the video down just a little bit, so because baby powder doesn't stay in the air very long. And so you see my light beams, that's definitely crepuscular rays. Look at that angle. And if remember, my camera is shooting straight and I am not directly under or lined up with the crepuscular rays. Okay, so now we're going to look at NASA's view. Okay, so now I'm going to raise up my light source and look at the holes. They're becoming more focused. And I'm going to raise up my light source, and you can see the holes are much more defined. And I raised my light source as high as I could. And look at this. It's as high as I could. My roof isn't very high, my ceiling. But I raised it up as high as I could so that I can create a faraway light source the way NASA describes. All right. So then I used the baby powder. Once I adjusted it, whoa, look at that. The light beams are almost horizontal, and they're not completely horizontal because my ceiling can only go so high. But look at the difference between this and the previous crepuscular rays that I created. They're almost completely straight. All right. Look at that. It's pretty cool. But NASA's right. When the light is really far above the obstruction, away from the obstruction, it creates horizontal light beams. But that's not what we see out in creation. And here we go. I think I'm going to hit it again with the baby powder one more time. You got to see this. Here it comes. All right. And like I said, I slowed it down a little bit. Look at that. Okay. But that's not what we see out in creation. So keep that in mind. All right. So what do we see out in creation? Right here. Localized sunbeams coming through the clouds. They're not everywhere, all over the place. But when you see the breaks, look at that. When you see the breaks, they're localized. They're just back here. They're not way over here. They're not all over the place. And they're always angular. And the photographer is not lined up directly under the corpuscular rays in order to get that convergence, because that's the only way you can get it if you count perspective. But look, it's angled all over the place. Okay, look at that. That's called anti-corpuscular rays, and that's called crepuscular rays. Really, anti-corpuscular rays is simply sunbeams that are pointed up. That's all it is. It's nothing special. So, but look, you don't see them all over the place, do you? Look, there's plenty of breaks in the clouds, and you don't see them all over the place. Let's look at another sample. Look at this. And so it's highly focused. Look at that. Look, they're not way over here. And you can look at the convergence. And the camera is miles away, miles away. In order for NASA to be correct, or modern science, you would have to be directly under the light source to see the convergence, and yet you're not. Okay? Perspective is point of view dependent only. Look, you can see it vaguely over here, but they're not everywhere. This is a video I shot at Beulah Beach at Take on the World 2019. And as you can see, look how close the sun is to the clouds. All right. The only way you can create crepuscular rays is for the light source to be very, very close to the obstruction. And guess what, folks? Though that sun is as close as it looks. It is, if it were 93 million miles away, then those crepuscular rays, look at that, those crepuscular rays will be going straight down. And in order for us to see them converging, we would have to be directly under the light source or close to under the light source in order to see that happen. I sped this up a little bit too, because you know how slow clouds can fly. So, but that's what we see in creation. All right. In conclusion, crepuscular rays is a silver bullet for enclosed cosmology. It answers a lot of questions. So we have here, one of the things it answers is perspective has nothing to do with crepuscular rays. You have to be directly under the light source in order for perspective to come into play. And yet it does not. Look, even in my background picture here, the camera is at the side of the crepuscular rays. It's even close to the crepuscular rays. Look, we're looking at what, 20 feet, okay? And yet it is highly angular. Look at those angles, all right? The sun and moon are close to the clouds in order to create light beams. You have to have close proximity to the obstruction in order to create crepuscular rays. That is the only way you can do it. You ask anyone who works on sets, you ask anyone who works on movie sets who have to create artificial crepuscular rays for the set design, for drama impact, okay, dramatic impact, and they will tell you their light source, studio lights, have to be close to the gobo. That's a photography term, meaning it has a board with holes in it, and the light source has to be very close. The sun and moon are much smaller than the earth. In order for the sun and moon to be that close to the clouds, it has to be much, much smaller than the earth. The solar system does not exist. That's a biggie, all right? In order for the sun and moon to be so close that they create this phenomenon, that means they are within our atmosphere, for lack of a better word. They are within our airspace, all right? And they have to be very local, very close. So therefore, there's no sun in order for the planets to rotate. Without a sun, there is no solar system. There's no way that planets can orbit nothing. Okay, the planets depend on the sun's gravitational pull. Without the sun, there's no solar system. planets do not exist. Okay, so what we're looking at here are planets. If there's no sun, there are no planets rotating around the sun. You see what I'm saying? There's a clear domino effect of conclusions here. All right, so if there's no sun, there's no planets rotating around the sun. Space and space stuff does not exist. Okay, this is huge because without space, there's no heliocentrism. Without space, there's no evolution. Without space, there's no Big Bang. Without space, there's no trillions and trillions of miles and stars and all this stuff. Without space, there's no rover on Mars. There's no ISS. Yeah, this sounds pretty big, pretty dramatic, but follow me with the logical conclusions here. All right. If the sun is within our airspace, then there is no space. Okay. This is a big one. There are no aliens. So, if you hear about, our alien brothers coming down to visit us and, free us and help us or attack us, you can call foul on that because there are no aliens, since there's no place for them to come. There is no space. There are no planets to land on. Yes, there are stars called planets, but there are no rocky balls floating around in the ever-expanding infinite cosmos. This phenomenon here, crepuscular rays, is one of the several silver bullets of enclosed cosmology. And it leads you to those conclusions. But you know what? Take all of these facts, take everything that you've seen here, and don't accept, verify.